Hello, good people. This is the first video for section 10.8, the ratio test for convergence. Before we get into the ratio test, I want to review some ideas that come up often with the ratio test, and they usually revolve around simplification of factorials and of exponentials. So just as a reminder, I'm going to write over here on the side. From an earlier math class, I'll say, you might remember what a factorial is, right? So this is a factorial. So this is not screaming 5 at us. This is just saying 5 factorial. And that symbol mathematically means that we start at the number and then we multiply every consecutive decreasing whole number all the way down to 1. So 5 times 4 times 3 times 2 times 1. So whatever this is, that's what 5 factorial is. So 5 factorial would be 5 times 4, which is 20, times 3, which is 60, times 2, which is 120, times 1. So that's 120. So I can figure out the value of that. But it's a shortcut of saying you're going to multiply starting from the given number and then in decreasing order all the whole numbers down to 1. So 10 factorial would be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Whatever that is, I'm not going to find the answer. So therefore, n factorial means I'm starting at n, and then I'm going to multiply it times the next number down. So I don't know what the number is. So I just take away 1. That's the next number down, n times 1, times n minus 2, times n minus 3, times ... all the way down to 1. So when I look at something like this, I can see that the numerator starts with n plus 1, and I'm taking the factorial. So that really means n plus 1 times n minus 1 times n minus 2 times yada, 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 all the way down to 1, right? Because we're supposed to multiply all the way down to the whole number 1. And then in the denominator, I can say n factorial, well, that's n times the next number down, n minus 1, times n minus 2, times ... all the way down to the number 1. But as I look at this, I realize, oh, we can reduce things. We can reduce the n's, and we can reduce the n minus 1s, and the n minus 2s, and the n minus 3s, all the way down to the 1s. So the only thing I have left is n plus 1. So this factorial divided by this factorial is equal to n plus 1. Now, some people will say in the numerator, my numerator is really n plus 1 times, and then all of this section is n factorial, and then in the denominator I had an n factorial, so the n factorials are going to reduce out, but that's what I reduced here in the way that I did it. I reduced all the values of n factorial. And then I'm just left with n plus 1. So that's one of the skills that comes up often when we use the ratio test. The other skill that comes up often has to do with exponential setups. So recall that whenever I have an exponential function where I have two terms in the exponent that I'm adding, I can rewrite that as 3 to the n times 3 to the 1. And if I divide that by 3 to the n, oh, my 3 to the n's are going to reduce, and then I'm just left with 3. So when I divide this exponential divided by that exponential, I just come up with a constant 3. So these two simplification techniques, one for factorials and one for exponentials, will come in handy as we do the ratio test. So what is the ratio test? Well, the ratio test says, if I have a series that has positive terms, so here's the key, here's the condition, I have to have positive terms. And then I take the limit, and there's something missing on the printed page here. I'm taking the limit as n approaches infinity of the absolute value, I'm taking the limit as n approaches infinity of the absolute value of a sub n plus 1 divided by a sub n. So that means the nth term, n plus 1th term, divided by the nth term. If I take that limit and I get an answer that's less than 1, then I know that the series converges. If I take that limit and I get an answer that's greater than 1, then the series diverges. But if I get an answer to the limit that's equal to 1, then the test is inconclusive. So in this video, I want to do some examples where the test is inconclusive because it turns out the ratio test doesn't work with specific types of series. And it doesn't work because I can't conclude what's going on. Okay, so these are the three cases, right? As long as my series has positive terms, if I take the n plus 1th term divided by the nth term, take the limit, depending on what the answer is, it's either going to converge if my answer is less than 1, diverge if my answer is greater than 1, inconclusive, I don't know. It could go either way if my answer is equal to 1. So we're going to look at number 1 here, and then we'll come back on the next video and look at number 2. You should be able to look at this and recognize this as a specific type of series. This is a harmonic, and we already know harmonics diverge. But I want to try this new test to see if it'll confirm that, right? And so I'm going to take the limit as n approaches infinity of the n plus 1th term. What that means is I'm going to take my equation, and wherever I see a variable, I'm going to replace it with n plus 1. So that's going to leave me with 1 over n plus 1. Wherever I see a variable, I replace it with n plus 1. Divided by the nth term, which is the formula itself, which would be 1 over n. I need to take the limit of this setup. When I do, that'll give me an answer, hopefully, and then that answer should point me to what happens to the series that we started with. Well, I have a fraction within a fraction, and that's kind of weird, so I'm going to rewrite this as the limit as n approaches infinity of, if you multiply by n on top and bottom, I think it becomes this. And that's a little bit easier. You can also think of it as multiplying by the reciprocal of the denominator, and then that's going to get you to this as well. Can you take this limit? Well, if I take this limit, n is getting bigger, but the numerator and the denominator are growing at the same rate, so therefore the limit is 1. Oh, well, that means that the ratio test is inconclusive. Now notice, I wanted to show you this for a couple of reasons. Number one, I want you to see that just because the ratio test doesn't work doesn't mean we don't know what happens to the series. Like, this is a specific type of series for which we know the outcome, but the ratio test would never be able to tell me that outcome. I have to do it another way. I'm going to pause the video. We'll come back in the next video. We'll do number 2, and then we'll get into some more ratio test determinations of convergence.